Right, huge interest in sigma notation here. And honestly, I just think that a lot of these just forgot the stuff that you did before Easter, and therefore this isn't going to make any sense. But it is crucial that you go back over it because it's all linked. Now, this is my second attempt doing this video. I say I had 30 minutes, lovely done. Then Plunkett gives me a ring, the whole thing goes. So that was heartbreaking, and it was tip tap. But sure, we'll give this a go again. And if it doesn't work and we get no views, that'll be the end of it. So you better all watch it now. Now, just have a wee recap of what has been done in this section, because I think, as I say, that is the problem. First bit, 4.2, is just looking at linear sequences, or they always use a swanky term, arithmetic sequence. So an example of a linear sequence would be something like the numbers 2, 5, 8, 11, 14, and so on. Now in this sequence, we can see commas between it. This here is called a term. Each of these are terms of a sequence. And to be precise, that's term 1. And instead of writing term 1, they write T1. There's T2, or term 2, T3, T4, T5. If they ask you for T6, it'd be 17, because we can see there that they all go up in threes. The common difference is 3. Now, to get the general term of that, general, or sometimes they call it the nth term of a linear sequence. A linear sequence because it's the same first difference. There's a certain formula. It's in page 20 or 21 of your formula book, and it is Tn is equal to a plus n minus 1d. Now, in this formula, it also tells you what a and d are for. It tells you that in the formula book. A is the first term. So the first term in this sequence is 2. So a is 2. And the common difference is plus 3. If it was going down the way, you would have to put in your minus. Now, if we want to get the general term, horse these values in for a and d. So Tn is equal to 2 plus n minus 1, and the common difference is 3. Just tidy this up. Brackets mean multiply. So Tn is equal to 2 plus 3n minus 3. Tn is equal to 3n minus 1, or minus 1 plus 3n. Now the beauty of this will give us any term in this sequence. So say I wanted the fifth term, T5, all I do is sub 5 in for n, like I have done here. I sub the 5 in for the n here, and I get 14. We know we're right because we see the fifth term there is 14. If I wanted the 20th term, I sub 20 in for n, and I get 59. And say if I wanted the 100th term, I sub 100 in for n, and I get 299. So imagine this was my income. I was getting €2 the first year, €5 the second year, 8 the third year, 11 the fourth year. If I wanted to work out what I get in a particular year, if my wage increased by the same amount each year, I do this, the general or the nth term of a linear sequence. Now in 4.3, they're looking at an arithmetic series. So an arithmetic, or again another word for an arithmetic, is linear. And the only thing different in a series is, say if we had these terms as well, so 2, 5, 8, 11, 14. The only thing different in a series is there's a plus sign between them. So they're adding up all the previous terms. So in a sequence, they're commas, while in a series, there's a plus sign. So if I asked for s of 2, they use the term s for series, where t is for the term. That means add together the first two terms of that series. So you'd have 2 plus 5 is equal to 7. Ask for s of 3, first three terms. 2 plus 5 plus 8 plus 11, plus 8. And we get 15. If I ask you for s of 5, we go 2 plus 5 plus 8 plus 11 plus 14 plus 17. 1, 2, 3, 4, 5. Ah, jeez, having a mare. Add up those 7, 15, 26, 40. Now, if they ask you for s of 100, you'd be all day writing out all those numbers. So they came up with a little formula for this as well, and that's given to you in your formula book. For the series, they use Sn. So Sn is equal to n over 2, 2a plus n minus 1d. Again, the letters still stand for the same thing. A is the first term, so up here we'll use this as the example. A is 2, d is the common difference, which is 3. Horse in these values. So n over 2, 2 times a plus n minus 1, and the common difference is 3. Now you could leave the answer like that, but a lot of the times it looks easier by tidying it up. There's two fractions there, two fractions, multiply them together, top by top, bottom by bottom. N plus 3n squared over 2. Now that's our general term there for our series. So if we wanted to work out what the first 5 terms is, we could sub in 5. Now that's as far as ordinary level even cert need to know. So just to show you, don't be thinking this is miles ahead from the ordinary level course. Ordinary level need to know these two things. So you need to know these immaculately. So we'll try S of 5 and we should get 40. So 5 plus 3 times 5 squared over 2. 5 squared 25, 75, 80 over 2, which is 40. That's all well and good if you've only got 5 terms that you can write them out. But if we did have that S 100, which I asked you up here, this here formula is a lot easier. 100 plus 3 times 100 squared over 2. Throw that in your calculator. 15050. So if there's anything there you're unsure of, pause the video, go back, study it, because you need to know these in order to have any hope of getting the rest of this chapter. So pause it and do a few questions from 1 and 2, or for 4.2 and 4.3. Now we'll look at sigma notation. Now this is going on from page 13 of your notes. Now it's still in the same section of arithmetic series, so it's part of that. So you'll often see in sigma notation this thing here. And that letter there is just a short way of writing maths. People are lazy. They don't want to be writing big sentences. So that letter there, Jesus, marvelous. That letter there is a short way of writing sum of, or if you like, add up all them things. Now they'll give you a starting point, so they might say n is equal to 1 or r is equal to 1, as I seen Jack was asking. Could be any letter, and this number at the top tells you where to stop. So I'll go to 5, say in this one, and I'll use a wee thing here, 3n minus 1. So this is like question, what is that, 6? Yeah, it's like question 6 in your book. Now, so that means add together the first 5 terms from 1 ending at 5, and these numbers go in for n. So like if I was working that out, one way of doing it is just simply going 3 times 1 minus 1, subbing in the 1 here for the n, which is 2. 3 times 2 minus 1, 6 minus 1 is 5. 3 times 3 minus 1, what are we at here, 8. 3 times 4 minus 1, 11. And 3 times 5 minus 1, just run out of space here. 15 plus 14, and we add up all those, 7, 15, 26, 40. Now if you look, that is the same answer as we got down here. And another thing to be aware of there, that 3n minus 1 is what we had over here. So when they're using sigma notation, they always have that tm, the general term, and after it. Now, what that allows you to get is them first few terms. So when they write it shorthand like that, it allows you to get these first three terms, but once you have these pluses in between, as we said up here, you have to use SN then. So way 2, because it's grand writing out the terms when it just says 1 is to 5, from 1 to 5, but that's like 1 to 100, like they have in 6 part 3. You'd be some time doing that. So once we see these pluses, we know we're using SN because it's a series. We've got our terms from this. A is equal to 2, D is equal to 3, SN and then fill in my A and my D here. And that is the exact same as this. So you'd end up with SN, we're down here, n plus 3n squared, because it's the same sum that you're doing. And therefore, if you wanted S of 100, the first 100 terms, you'd fill in your 100 for n. And the way they'd write that, using your sigma notation, they'd ask you to do this. This would be the question. N is equal to 1, all the way up to 100 of your 3n minus 1. So if they ask you that, you write out the first few terms to get your A and your D. And since this means sum or add together, you're going to have to do your SN. So it's a combination of all of them. We'll do actually we'll do the other example in your notes. So the other example in your notes is page 13. Jeez, the effort. So page 13. Example. So this here has a sigma. Automatically that means sum of 2n plus 3. And it's from 15, or from 1 to 15. Now remember, every time there's a sigma, there's a tn and after it, your general term. That allows you to get your first few terms. So we'll get the first term. We're starting at 1 here. 2 times 1 plus 3, which is 5. 2 times 2 plus 3, 4 plus 3, 7. 2 times 3 plus 3, 6, which is 9. Now you could keep going. It wouldn't take you a lifetime to write out 15 terms there and add them up. But we'll do it using our SN. You need to do that in order to get your A and your D. A is 5, D is plus 2. And remember that there, sigma just means sum of. So when it's a sum of, we're using our sum of an arithmetic series, n over 2 plus 2, A plus n minus 1D. Throw in your values, n over 2. Tidy that up. When you get this far, just remember we've got brackets. What do brackets mean? Multiply, and you're multiplying together two fractions, top by top, bottom by bottom. You can leave it like that. You can also simplify it because 2 goes into this. So 2 goes into 8n, or 2 goes into 8 4 times. 2 goes into 2 once. And there you go. You'll be able to work out any amount of terms. Now they ask you to work out the first 15, so we sub in 15 here. (15 squared) 225 plus 60 285, and that's it. Now just to show you, say if I did want the first 3 terms, since I have them there, S of 3, just to make sure we're right. 4 times 3 plus 3 squared, 12 plus 9, 21. Add them up, 5 and 7 is 12 plus 9 is 21. You know, so we're flying. I'll do, as I say, 6 part 2, because I know it just looks a wee bit different. And this is page 149. And you've got 4r minus 1. R is at 0. and we're going as far as 5. Don't be put off by the letters. So remember, that thing there is my Tn. It'll allow me to get the first few terms. Now to get those first few terms, I'm starting here. So it's 4 times 0 minus 1, which is minus 1. We're going all the way as far as 5. 4 times 1 minus 1, which is 3. 4 times 2 minus 1, which is 7. Now you could easily put in the next two terms, feck it a will. 4 times 3 minus 1, which is 11. And 4 times 4 minus 1, which is 15. Now what does this big buck mean here? That there, the sigma, begin with an S, stands for sum. How do you find the sum? You add up these lads here. Now when you add them up, what do we have? 2 and 7 is 9. 20, we get 35. So the answer to that problem there is 35. That's one way of doing it. I'll show you the other way, because more than likely in your leaving cert, that's way 1 say. You'll have a lot more terms than 5. So your second way, once you see these pluses, that means add them together. You just have to write out a few to get your A and your D. A is minus 1. D is, what do we got up in 4s? So Sn, n over 2, 2A, en chien, and minus 1D. And tidy that up. Here, you see brackets. Brackets may multiply again. Two fractions, squeeze them together, top by top. 4n squared minus 6n over 2. And then you can simplify that. The more you simplify, the easier it'll be to work out values. 2 into 4 goes 2. 2 into 6 goes 3. So there's my Sn. And what did they ask me? This is what I put in at the end. So for S of 5, now we know the answer should be 35. So it puts the pressure on us to get this right. 5 squared, using your BIMDAS, 25, 50, minus 15, 35. We're good. So this is probably the way you'll have to do. So recapping that, sub in here, and maybe go 0, 1, 2, sub in the first 3 terms. Here we start at 1, first 3 terms, 1, 2, 3. That allows you to get A and D. And then fill it into your Sn, because this boy here means the sum of. Now how long is that? 18 minutes. This is where I started going crazy the last time. You try there for yourself. Page 14 on your notes, the question 1 at the top, and also question 6 from your textbook, page 149. Now they're all like that, so practice them examples and do them. You really do have no excuses now. Right, so pause the video. I'm gonna chance going on again. Now, this next example is from page 14. So here they've got use sigma notation to represent this for 45 terms. So they've given you 2 plus 6 plus 10 plus 14. So I know that's a linear sequence. It's a linear sequence because they've got the same first difference. They're all going up in 4s. Now they've asked you to use sigma notation, so they want at the end of this that with something thrown in after it. Now we know what always goes in after that, Tn, the nth rule, and it says for the first 45 terms. So there's 45 up there, and we're starting at 1. That's all it means. So in order to get me sigma notation, I must get Tn. So we'll find Tn, and I'll stop after this one because the phone's making noises. So A plus m minus 1d is my formula. A is the first term, which is 2. D is my common difference, which is 4. So Tn is equal to 2 plus m minus 1 times 4 under pressure here now. n is equal to 4n minus 2. Therefore, this in sigma notation is 4n minus 2, start at 1, going to 45. That's your answer. You know, an easy way to check if you're right, sub in 1. 4 times 1 is 4, minus 2 is 2. 4 times 2 is 8, minus 2 is 6. We're laughing. That's all you have to do. So I'm stopping and I'll stick another one up then.